In question 16, we determine the radius of a cone given that the volume equals 168 centimeter cube and the height is given as 9 centimeter. So let's utilize this volume formula to determine the radius. We have volume equals 1/3 pi r squared h. Now replace the volume V by 168. So therefore 168 equals 1/3 pi times r squared, and now replace the height h by 9 centimeters, so this becomes 9. Now we should solve for r squared from this equation. So we should have r squared on the right side and every other term on the left side. That means we multiply by 3 first, so 168 times 3, and this equals here we have pi times r squared times 9, and so now we should divide both sides by 9 pi, so that we get r squared on the on the right side. So this will become 168 times 3 divided by 9 pi equals r squared. Let's simplify the left side expression. We could cancel this 9 with the 3 as 3 times, and now this 168 goes into 3 as 56 times. So we have 56 over pi equals r squared. And this implies we take a square root on both sides so that we determine r. And so this gives r equals square root of 56 over pi. Or else we can simplify this radical. That is r equals, I can write this as square root of 56 divided by square root of pi. And now this 56 inside the square root can be written as 4 times of 14. We write this as a product of perfect square so that we can simplify this. And square root of 4, we know that it is 2. So we have 2 root 14 divided by root pi, or otherwise we write this as r equals 2 times root 14. You can write it as 2 times of square root of 14 by pi. So this is the value of r. The decimal approximation of this one equals 4.22, and this is in centimeter. So this is the value of r, which is the radius of the cone. This is also centimeter. Okay, in question 17, let's say that x be the integer. And according to the problem statement, let's write the statement into mathematical equivalent. So 5 is added to the integer. So we are adding 5 to the integer first, and then it is being quartered. So we are just quartering this. That means we should multiply this by 1/4. So x plus 5 times 1/4, and then this one is squared. After this, we are squaring this. So we square this quantity. This means we have to square this expression, that is x plus 5. This expression is divided by 4. We square this like this, and then this sum equals 9. This is what given. So we have written the mathematical statement of the given problem statement. So this is the equation. From this equation, we have to solve for x. And so this equals x plus 5 squared divided by 4 squared equals 9. This 4 squared is 16, so I'm changing this to 16. Now we multiply both sides by 16, and this gives x plus 5 squared equals 16 times 9. And 16 times 9 equals 144. So let me change this to 144. Now let's write down or expand this binomial square. This equals x squared plus 10x plus 25 equals 144. We are using this binomial square identity, that is a plus b quantity square equals a squared plus 2ab plus b squared. So here a is x and b is y. When we use this identity, we get this expression, or otherwise we can also expand this by multiplying the factor with itself, x plus 5 times x plus 5, and then foiling out. So basically we get this expression on the left side. Now subtracting 144 from both sides, we get x squared plus 10x minus 119 equals 0. And this one is a quadratic equation. So to solve for x, we can use the factor method or the formula method. Here I'm going to use the factor method. So here we have to find two numbers such that their product is 119 and then their sum is positive 10. So I'm going to try with 10 and 7. No, I try with the 17 and 7. 17 times 7 is positive 119. But since we want negative 119, we could change one of the number to negative number. Either we could make this as negative 17 or we could make this as negative 7. But if we make this as negative 17, when we add these two, we get negative 10. But here we want positive 10. So I'm going to change this negative 17. Instead, I make this as negative 7. Now, when we multiply these two, we get negative 119. And then when we add these two numbers, we get positive 10. So it is perfect. So we have identified the two numbers are 17 and negative 7. And this means in the next step, we can write as factor form by writing this as x plus 17 times x minus the other number. And so this equals 0. Now using the zero product property, we set up two equations. That is either x plus 17 equals 0 or x minus 7 equals 0. And solving this, we get x equals negative 17. Solving this, we get x equal positive 7. So therefore, we see that the two integers, here we get two integers are negative 17 and positive 7. In question 18, we determine the exact length of one of the edges of the cube. Uh, the surface area is given as 120 centimeters square. So the formula to find the surface area of a cube is 6 times the a squared, where a represents the length of the edge, and this equals 120 centimeters squared. So just put 120. Now dividing both sides by 6, we get a squared equals 120 divided by 6, and this equals 20. And so therefore we get a squared equals 20. Taking square root on both sides, we get a equals square root of 20, and this is in centimeter. We can give this in simple form. So a equals square root of 20. We write this as a product of a perfect square. 4 is a perfect square, and we can take the square root of 4, which is 2. So this is 2 root 5 centimeter. So this is the exact value of length of one of the edges of the cube. Otherwise, we give its a decimal approximation. This is approximately equal to 4.47 centimeter, rounded to two decimal places. So either it is 2 root 5 centimeter or 4.47 centimeter. Let's do question 19. So here let's say that x be the integer. And so its square will be x squared. And then 30 less than this square of the integer, that is x squared minus 30. And this is given as 139. So we converted the given problem statement into mathematical equation, that is x squared minus 30 equals 139. And this means we can solve for solve for x squared by adding 30 to both sides. So we get x squared equals 139 plus 30, and this equals 169. So here we have x squared equals 169. So we take square root to both sides to solve for x. And so this gives x equals square root of 169 is plus or minus 30. So therefore the integer is either positive 13 or negative 13.